All right, we're on 7.5, solving rational equations. This is our second video, and this time we're going to solve these rational equations by using our least common denominator, or LCD. Okay? All right. So we will need to check our solutions as we go, because remember, we cannot have a denominator that is 0. All right. So we need a least common denominator. So I like to list those. So I always write my LCD, least common denominator, okay? So if I look at all my denominators here, I have a denominator 7, denominator of x, and this one doesn't have a denominator, which means its denominator is 1, okay? So if I look at my constants, I have a 7 and a 1. I want to make sure both numbers can go into the same number. So 7 can go into 7, and 1 can also go into 7. But 7 can't go into 1, okay? Because it would give me a fraction, right? So I know 7 has to be in my least common denominator. And then the only variable I have is x, so it also has to be in my least common denominator. So my denominator needs to become 7x, okay? So when I start this, if I'm just going to write my first fraction, 4 over 7, but my denominator is 7 here, but I need it to be 7x. So I need to multiply this denominator by an x. If I do that on the top, or on the bottom, I have to do it on the top. Okay, then my equation had a minus, and it's 1 over x. And again, this needs to be 7x, so it's just missing the 7. I need to multiply it by a 7. And if you do that in the denominator, you have to do it in the numerator. Then I have equals 6 over 1. That denominator needs to be 7x. So I need to multiply that denominator by 7x, and therefore I have to multiply the numerator by 7x. Okay, so now everything is going to have a 7x on the bottom. So you can basically think of it as, well, let's ignore that. But what we're doing is actually multiplying everything by that 7x. So it makes our denominators just go away. But for all the purposes right now, I'm going to go ahead and write them. But after this problem, after this step, I do not write the denominator anymore. Okay? So this one becomes a 4x over 7x minus 7 over 7x equals 42x over 7x. Okay? Now here's where I said we can just multiply everything by 7x and all of our denominators go away. So we end up with 4x minus 7 equals 42x. And it's just a matter now of solving for x. Okay? So I'm going to subtract 4x from both sides. I get a negative 7 equals a 38x. And I divide by negative 7. No, I don't. Oh, my Lanta. I divide by 38. I'm trying to get x by itself. Oh, goodness. All right, so over here, this 38 went away. I'm left with x, and it equals negative 7 over 38. Okay, that doesn't simplify down. You'd have to end up rounding, so just leave it. Just leave it as a fraction. It's exact answer. Okay? Now, checking solutions, if I were to plug that in the denominator, in for x, I only have to look at the denominator that has an x in it. Would it be a 0 in the denominator? No, my denominator would be negative 7 over 38. So it works on this problem. So let's go to number 6. Okay, let's find our least common denominator. So think of each of these as one term, okay? So I have x plus 1, I have an x plus 2, and I have an x plus 2. Well, our denominator has to include all of those terms. So it has to include an x plus 1. It has to include an x plus 2. And then I have another x plus 2, but I already wrote it in my denominator, so I don't need to do it again, okay? You don't have to write it more, because then that wouldn't be the least common denominator. It would just be a common denominator. So I just need the two binomials, okay, because one of them is repeated, so I don't have to write it again. All right. So if I have this first fraction in my problem, it is 3 over an x plus 1. Well, I need the denominator to be x plus 1 times x plus 2. So I need this one to have times an x plus 2. If I do that on the bottom, I have to do it on the top. All right. Continue your original equation. It has a plus, and it has a 4 over x plus 2. Okay. So that denominator has the x plus 2, but it's missing the x plus 1. So I need to multiply by the x plus 1, and I have to do it to the top as well. Then if I continue my original equation, it equals 15 over x plus 2. And again, my least common denominator says I have to have x plus 2, but it has to be multiplied by x plus 1. So I'm missing the x plus 1. All right, so like I said in the last problem, I'm just going to, at this point, all my denominators are the same. So if I multiply everything by that denominator, they go away. So I'm done dealing with those. So I just have what's on top here. So I have 3 times x plus 2 plus 4 times x plus 1 equals 15 times x plus 1. And let's do all that distribution that we need to do. So I get 3x plus 6, distribute the 4, so it gets plus 4x plus 4 equals 15x plus 15. Combine some like terms here on the left side. I have a 3x and a 4x makes 7x. I have a 6 and a 4, so that makes 10. And that still equals 15x plus 15. Okay, so we just need to solve for x. So I'm going to move up over here on the other side. I'll write down my next step first. Let's move to where x's stay positive. So I'm going to just subtract 7x. You don't have to. X could be negative. It's fine. But now on this left side, I'm left with a 10. On the right side, I have 15x minus 7x is 8x. And then I have the plus 15. Still need to get x by itself, so I'm going to subtract 15. So I get negative 5 equals 8x. To get x by itself, I divide by 8. Okay, so I get x is negative 5 over 8. And again, you need to check your solution. If I plug it into any of these, the only thing that would make this 0 would be a negative 1. That's not negative 1. The only thing that would make this 0 is a negative 2. That's not negative 2. And the same thing with that one. So this does work. This is my solution. Okay, we're going to skip number 7 for now. Go on to number 8. Okay, so we need to find our least common denominator in number 8. So let's write, I feel like I didn't give myself enough room, but least common denominator. And again, remember, this is one term, this is one term, and this is over 1, which multiplied by anything is itself, so I don't put 1 in my least common denominator, okay? All right, so my least common denominator has to include an x minus 1, and it has to include an x. And you can write that in front of it or behind it, it doesn't matter. But both of those terms have to be in the denominator. So if I write out my initial equation, I have a 3 over 1, I'm going to leave a little space, minus 18 over an x minus 1, leave a little space, equals a negative 12 over x. Okay? So let's make all of our denominators be the same, and we want them to be that least common denominator. So in the very first one, my denominator is 1. It needs these two terms. So I need all of it. And I'm going to just move x to the front for the sake of this one. So I'm going to multiply this times an x times an x minus 1. So this is times an x minus 1. Okay? This next fraction is missing the x. It has the x minus 1, but I need x, so I need to multiply by x. And I multiply by x. Okay? The last fraction here has the x, but it's missing the x minus 1, so multiply by x minus 1. Multiply by the x minus 1. Okay? So all my denominators now are x minus 1 times x, or you could say x times x minus 1. So all of these are the same now, so we'll kind of ignore them, because we can multiply everything by that, by our denominator, and then the denominators cancel out. So let's go from here. So now when I do some distribution here, I have 3x, because 3 times x is 3x, right? So I have 3x times an x minus 1. So that gives me 3x squared, because I have 3x times x, and then I have 3x times a negative 1 is a negative 3x. Then I have minus 18 times x, so minus 18x, equals negative 12 has to be distributed, so it's a negative 12x plus 12, because negative 12 times x is negative 12x. Negative 12 times a negative 1 makes a positive 12. Negative times negative is positive. All right, and we just need to combine some like terms. I see that I'm going to have a quadratic, so everything will eventually be moved to that side, but right now let me just combine these two terms right here. I have a negative 3x and a negative 18x, so that makes a negative 21x. Instead of rewriting everything, I just wrote it as 1, okay? So those became negative 21x. So let's move the 12x and the 12 over. Okay, and I'm going to rewrite it up here. Okay, so we end up with 3x squared, and I have a negative 21x and a positive 12x makes a negative 9x, and then it looks like I just subtracted 12, so I just have a minus 12, and it equals 0. So we want to factor this, okay? But everything is divisible by 3, so I'm just going to go ahead and divide everything by 3, and I get x squared minus 3x minus 4 equals 0. So that makes it a little easier to factor. So they all have an x. Now, it has a minus 4, so one has to be negative, one has to be positive. They multiply to negative 4, but add up to negative 3. So if I have a 4 times 1, and that 4 is negative, that adds up to negative 3 and multiplies to negative 4. All right, so this is going to give me, since that's x minus 4, it gives me a positive 4. X plus 1 equals 0, so it gives me a negative 1. And we need to check that none of those turn a denominator to 0. So I have a 4 minus 1 is 3, so that's good, and then I would have a 4. So the 4 works. And then I have a negative 1 minus 1 is negative 2, and then that'd be negative 1. All right, so now go ahead and go to your practice and do numbers 19, 22, and 23 and move on to the third video.